Hi everyone and welcome to the new video. My name is Dimitri and I work as an embedded software developer. Today I want to show you a very interesting Meshtastic board. It is SenseCAP Solar Node P1-Pro made by Seed Studio, and it is interesting for several reasons. First, it has a large solar panel and it can work fully autonomously. It can work outdoors and, as we will see, also indoors. The SenseCAP node has an internal battery, so it can work also as an emergency communication device. Last but not least, it can be upgraded with external sensors, and in this video I will show how to do this. Please be aware this is a combined video made from two parts that I did before. It is just easier to have a full review in one place, and it is also optimized to watch on TV. But if you already watched two parts, you don't need to watch it again. And now let's get started. But first I want to say thanks to OpenELAB web shop for sponsoring this video. OpenELAB sent me this board for testing. Please keep in mind that this review is independent. It is not a paid advertisement and I will tell you my personal opinion about the product. And now let's get started. And first I will briefly explain what is a Meshtastic. As we can see on the page, Meshtastic is an open source decentralized network. And it is a very interesting technology because it is a mesh network. When the node receiving a message, it can forward it to the next nodes and so on. Also, as we can see that these messages are encrypted. You can have public channel and you can create a private channel. Also, because it is a mesh network, nodes can communicate with each other even if they are not in a direct line of sight. Meshtastic also has a phone app, so people can use it as a standard messenger. And there are many use cases for that. You can exchange messages with other people even in the middle of nowhere, where there are no internet providers available. Or you can use it for IoT purposes, for example, to send the telemetry data. Nowadays, Meshtastic ecosystem is rapidly growing and there are many devices on the market. For example, there are Meshtastic devices with the keyboard, made in the style of the old BlackBerry phone. There are portable devices that can easily fit in the pocket. There are DIY solutions like this Heltec board. I also did a review of it, feel free to watch it if you want. As we can see, there are different regions and different frequencies. So before using the board, you need to specify the proper frequency, you need to specify the region. So you can read the documentation on your own, and now let's start with the test. As for this SenseCAP board, there are two models available. Apparently they have the same hardware, and the only difference is here. A P1-Pro board has the batteries installed. There are four 18650 batteries, and it also has a GPS module. Other specs are the same. Do you really need GPS or not? It's an open question. In my opinion, this node is stationary, and if you put it on the roof or something like this, you can just specify the coordinates in the phone app and that is it. So technically you don't need the GPS. GPS can be useful if you're going to install this node on a van or something like that. Then the coordinates may be changed, of course, and having a GPS is important. Apparently, at least for now, the difference is only 10 euros. So practically it may be cheaper to buy the board with the batteries included, because I think that on Amazon the batteries will be more expensive. And now let's configure the board and see how it works. Finally, it's time to test the real device. And from this picture we can already get the idea. We have a big 5 watt solar panel. We have a mounting bracket and we have an antenna. Let's open the box and see what is inside. And the first thing I see is a large solar panel. This Seed Studio node is ready for outdoor mount. Here I can see some connectors and we will figure it out a bit later. We also have a short installation manual. This is the antenna cable that allows to put the antenna a bit higher. This can be useful. Also keep in mind that you should not connect the device without the antenna, otherwise you can burn the transmitter. This is a bracket for mounting. Obviously we can screw it in place. Last but not least, we have some cables and mounting screws. Now it's time to configure the board and see how it works. And because it is a new device, as a first step I will update the firmware to the latest version. First I connected the antenna. As I mentioned before, you shouldn't connect the device without the antenna, otherwise you can damage the transmitter. And the next step is easy. I must connect the node to the computer and open the website flasher-meshtastic.org. We can see the URL on the screen. As we can see here, there are many nodes available, and first I need to select Seed Studio. And here is the node I have, SenseCAP Solar Node. Various versions are available. I decided to select the beta version. You can choose the alpha if you want. And here we have two buttons, flash a new firmware or erase flash. This board was not used before, so I don't need to delete the old data. And here we can see a changelog. And the flashing itself is easy. I need to press the button Enter DFU mode. First I need to select the serial port, and I need to be sure that the port is present, otherwise I need to check the cable. As we can see, everything is fine. And now I can see that the new drive appeared in my system. And I need to press the download button and to save the firmware on this drive, and that is it. Apparently the microcontroller has restarted because the drive disappeared and I see no messages on the screen. Now I can open the Meshtastic app and connect the new device to my phone. Okay, now the firmware should be updated and let's see how it works. I'm pressing scan and we can see that new board is available. The recommended pin is 000. Obviously there is no screen here. No, 0 did not work. I checked the manual and it turned out that the code 1, 2, 3, 4, 5, 6. And as we can see, the board is connected. I will check the settings. First I need to set my region. I live in Europe, so I set a European region. All other settings I will keep as default. And after pressing save, the board should be restarted. I had to restart Meshtastic app, and after that the board is connected. We can verify the board settings. Maybe I need to change the board name. I can name it P1-Pro. As we can see, it works, and the board already got the first message. Okay, now the node is configured and let's see how it works. All Meshtastic functionality is available via the app. It may be surprising because Meshtastic is designed as an off-grid communication, but the thing is, the phone is using only the Bluetooth connection and all radio communication is done by the Meshtastic node itself. So practically you don't need internet or mobile data to send and receive Meshtastic messages, especially for the node like this with a solar panel. Let's say if the power will be down in the whole city, this node will continue working, and I will be able to send and receive messages from other nodes, while my phone has a power, of course. Still, it is cool. And the Meshtastic app is pretty powerful. As we can see, this node is pretty big, by the way. Meshtastic app has a lot of features, and its interface is convenient for people who use messengers, so it's easy to use. For example, we can have a public channel, we can see different messages, we can scroll them. We can also see the list of available nodes, and as we can see, this list is pretty large. As the name suggests, Meshtastic is based on mesh technology, so nodes can retransfer messages one to another. We can send and receive messages to the public topic. We can also send and receive message to the specific board. For example, here I have a Heltec board. As we can see, its ID is B62C. I can select this node in the app, open menu, direct message and send hello world. Practically the message was sent via Bluetooth to this big node, and this P1-Pro node sent it via the radio interface to this board. Now I can open this board and we can see this blinking icon. And we can see this message on the screen. The same way it works in other direction. If someone is sending me a message, it will appear in the phone app, and I will get also an Android notification for that. So the app is pretty powerful. And I must repeat again that this network is completely off-grid. All communication is based on radio waves. It will work without internet, without mobile data. Meshtastic app has an internal map, and as we can see, lots of nodes available on the map. Also, we can change the parameters. If we have several boards, we can switch between them. So as we can see, the app works well. And now I will show what is inside the node, and I will keep it running for the test. I know that the curiosity killed the cat, but I am still curious what is inside this node. So I am opening it for the viewers, and let's see what's inside the box. And as we can see, the process is simple. There are only screws around. No special screws, no glue. That is nice. And now let's see what is inside. As we can see, most of the space is consumed by the batteries. Here we have the antenna connector, and this is probably the LoRa module because the wire is going here. As we can see, it is a specially designed board, and we see the label Meshtastic repeater. And we have 3 buttons: power, user, and reset. As we can see, the design is good and it is also waterproof. Now I will close the case back, and as a first test I will just keep the board running for several days on my window. Why it is important? This P1-Pro node has a solar panel and the battery, so it can be really good as a backup solution for the emergency communication. Even if there is no electricity, it will work. So I will keep the node running on my window for several days, and I will see if the solar panel is enough to keep the battery charged. And while the data is collecting, I also can do the range test. A range test is a cool feature of Meshtastic, and why it is important? Well, if you have different nodes or different antennas, you can run a range test and see what the real range will be. For example, I have this TTGo board that I used before, and it works well. It allowed me to get about 1 kilometer range. And this P1-Pro node definitely has a better antenna, but what will be the real difference? To answer this question, I can just run a range test and see a result. Let's do it. Doing a range test is generally simple, but it requires some steps. First, I need to open the board settings, go to channels, select the primary long fast channel and set the location. Here you can change the accuracy, because by default the accuracy is about 1 mile, which is too big. With the default precision of 1 mile, you will just see no points on the map. As you can see, in my case it's set to 300 feet, which is good enough. Optionally, if your node doesn't have a GPS, you can go to device configuration and set the position. You don't need to have a physical GPS, you can just enter the coordinates. Then you go to the module configuration, and here you can select the range test. So here I am enabling the range test on the P1-Pro node, and I will set the interval to 1 minute. Now I can press save and the node will be restarted. And after that, the P1-Pro node will start sending range test messages every minute. They are disabled by default, so they will not disturb other people. And now I need to enable range test on my second board. As a second board, I will use Heltec V4. I will take it with me and it will be my receiver. The log will be collected by the Android app and I will show later how to analyze it. But first I need to enable the range test on the Heltec board as well. But on the receiver board, I don't need to enable sending the messages, it will only receive. In the same way as before, I need to go to channel settings and I need to set the location accuracy. Optionally, you can also enable the precise location, which makes sense if you are walking with the node. And now I can open the main channel and I can see the messages. Important thing is that the range test is disabled by default, so it doesn't disturb other people. And now I'm ready to go for the walk. Okay, now I returned back and I can show how I can analyze the data. First, I need to open the Meshtastic app. Then I scroll down and select Export All Packets. Then I need to save the file on my PC. This is just a standard CSV file that looks like this. In this file you need to keep only the header and the range test packets. Other data you don't need. Then you can open Google My Maps. Here I'm selecting create a new map. I can name it something like P1-Pro test. Then I'm importing file I saved. And here the UI is simple. First I'm selecting the receiver latitude, and this will be my latitude. I'm selecting the receiver longitude, and this will be my longitude. And as a title I will select a distance. And here is the result. And as we can see, the result is interesting. I live in Amsterdam and I was walking in this area. And the result is really interesting and it surprised me. In my previous test I used the TTGo node that you see on the video, and the distance was exactly like this. This P1-Pro node has definitely a better antenna, it has higher gain, so the signal will be a bit stronger. But interestingly, the result is mostly the same and most of points are here. Most of the points are exactly the same, and the distance is a bit higher than 1 kilometer. As we can see, it's 1.2 kilometers. But surprisingly, one of the nodes got extremely far compared to others, and the distance was 2 kilometers. So technically, as we can see on the screen, most of the points are located in this area, but because of the antenna with a better gain, one signal somehow managed to travel almost twice distance. So as we can see, this antenna is good, it's better than on the previous node, and it is obviously bigger and it has a higher gain. But of course it happens only once. I got only one packet from such a distance, so it's not reliable. Because I think in the city it mostly depends on the line of sight and the radio signal is blocked by the building. Still, it's interesting to see that the better antenna allowed me to get the longer distance, practically twice longer. So to summarize this test result, I think this P1-Pro node has a good antenna with a good performance and I like it. And now let's go forward. Earlier in this video I promised to show my long-term solar panel performance, and I think now it is time to do this. But first I want to talk a bit about the mount. As we can see from this box, a SenseCAP Solar Node is designed to be mounted on the pole or on the wall. As we saw from the unboxing, there are special brackets and connectors included. However, the challenge for me is that I live in the city and I don't have a pole nearby, I don't have access to the roof. And I also don't want to drill my wall to put this node. So as you saw from the video, I just decided to keep it on my window and it works fine. It's even better for the test, because indoors the sky view is limited, so during the day I have less sunlight. And practically if you put your SenseCAP node outdoors, it will get more electricity than I got. As for the solar power itself, I have no problems with that. I can open the node, I can scroll down and select device metrics. Now the SenseCAP node is running for 2 weeks, and as we can see during last week, the battery level is not going lower than 95%. So practically it is always charged. I think it's a good result for the window installation. But just keep in mind that now it is summertime for me, and depending on the month and your location, the solar installation can be different. For example, if you live in Norway and it is winter, the solar panel performance will be definitely lower. Still, at least for the current installation, I think it's a good result and I'm happy with that. And now let's go forward and I will show you how you can easily upgrade this node. In the comments section for the previous video, one of the viewers mentioned that the SenseCAP Solar Node has a port for an external sensor. I checked the manual and it is indeed true. SenseCAP Node has a standard port for the E2C bus, and Meshtastic has an internal support for the big variety of sensors. You can see the list on your screen, and as you can see it is pretty big. In the Seed Studio page, the sensor port is called Groove, but practically it's just a standard E2C bus. You can easily find the pinout online, it looks like this. I did an order on Amazon for the BME280 sensor. As you can see on the screen, the cost is about $13 for 2 items, so it's about $6–7 per item. And for this price you get a sensor not only for the temperature but also for atmospheric pressure and for humidity, which is nice. And I also have found a proper cable in my box. I actually don't know when did I buy it. It was an old one, but it does the job. I soldered this cable. Obviously during the soldering you must check that the pinout is correct. And when it's done we can connect the cable and turn on the node. As a next step you must open the Meshtastic app, go to the telemetry settings and enable the environmental metrics module. The Meshtastic app is smart enough. It will scan the E2C bus and automatically find the proper sensor. You don't need to do anything. And after that the node will be restarted, and after some time you can see the new data. And as we can see, there is an atmospheric pressure here. I also can see humidity. I am making this video during the summertime. It was a heat wave and the temperature inside is 32 degrees, so it is pretty hot. Obviously the next question is how you can put these sensors inside the node. because the box is sealed, and if you close this, the temperature, humidity and pressure may be incorrect. However, as you can see, there is a port at the right. You can drill a hole here, fix the wires with a hot glue or something like this. The case is made from plastic, so it should be easy. As for me, I am running the node on the window, so I just decided not to close the box. In this case, the pressure and humidity will be more or less accurate. And as a bonus, you can open the Meshtastic app, go to telemetry and see the graph for several days. For example, it is interesting to see how the atmospheric pressure is changing or humidity. It is nice to see the graph. And if you're going to install the node outdoors, probably you can find the professional sensor kit with the proper waterproof housing. Alternatively, you can make a DIY solution. It is part of fun, right? And now let's make a short summary. As a general impression, I like this SenseCAP Solar Node and it works well. It has a good antenna, it has a 5-watt solar panel. The node has internal battery, it can work autonomously and even can be used for the emergency communication. As a disadvantage for me, I would prefer this node to have a stand for the indoor mount. This mounting bracket is kind of okay to be used in the barn, but for the home installation it just doesn't look attractive. Not everyone has access to the roof nowadays, and lots of people live in the cities, so I hope that Seed Studio can make an indoor version as well. But in general, I like this node and it works well. Thanks OpenELAB for sending me this node. If you want to buy the same one, the links are added in the description below. I am planning to do more interesting Meshtastic tests. Feel free to press like and subscribe if you want to see future videos. Thanks for watching and see you next time.